All right, let's start. Thank you very much for inviting me over. I'm going to skip these slides. These are about me, and probably a PDF later that can be distributed. One thing I have to say, the views presented here are my own. They're not APG's. So what I did is create a presentation. I've been at the forefront of serious IT, so larger organizations, complex landscapes, etc., for, say, roughly 40 years. I started in IT even longer, even before that, but I've been in IT for a very long time. And what I'm going to do is I'm going to try to present to you a couple of usable insights, what I've gathered from, say, being 40 years surfing the wave of the information revolution. And of course, surrounding the idea of being an architect. But before I do that, I'm going to start with a small prologue. As, of course, originally engineer, we start numbering at 0, right? So there are two aspects really important. One is you have to understand certain fundamental properties of IT. If you are a digital architect or an architect, business architect, whatever, in these kind of landscapes where there is a lot of information technology. But there are also very important characteristics of humans that you have to kind of understand. So, and your organizations and society, because they're crucial too. And to start that off, I'm going to show you this little picture, and some of you may have seen this already. The question is, which square is darker, A or B? Let's make it a little bit more easy. So, which square is darker, A or B? Now I'm going to ask you a little bit quickly because I have to really go fast today. Who says A is darker? Right? Okay. Who says B is darker? Nobody? Who says they are the same color? All right. Well, here's what happens if you move square A to square B, and then you see they are the same color. Now you can of course say, listen guy, you made that yourself, and I did. So you sneakily also changed the color while you moved that thing, right? So let's do it differently. Let's do it like this. And now you see they have the same color, and even now you will maybe see that the effect of the whole context around it says, no, they're not exactly the same color. So let's remove that. And then you can see they're exactly the same color. And I know absolutely certain because I created this myself, so it has absolutely the same RGB values. Now, this is called the checker shadow illusion. And the story of the checker shadow illusion is like this. A seems darker than B, but that isn't true because they actually have exactly the same color. The interesting thing is that it's not an illusion at all. So this is known as the checker shadow illusion, but it's not an illusion. What happens is, this is a fundamental characteristic of our brain, of our intelligence. What our brain tries to do constantly is try to find out what's the reality here. So the reality is that if we see something that is a shadow, we're going to subtract the shadow. And then we find out that if you remove that thing and there is no shadow, then B is really lighter than A. So the people who said B is lighter than A, they are right because your brain says that's reality.
That's why I don't know if you got it, I said B is on a white square.
Yeah, right. So that is your brain saying, what's the reality here, even if exactly the same color enters your retina. The fact that it's the same color is completely irrelevant to your brain. Now, interestingly, so we look deep. We are constantly calculating in that brain, constantly, quickly. So actually, realistic painters are really good at superficial looking. Right. These are known too. This was the dress from 5 years ago. Some people see blue and brown, others see white and gold. There is a little picture there which I made explicitly small. You see a red Coca-Cola can, but there's no red in the picture. Again, what happens here is that your brain says there is a cyan color over the entire picture. So it subtracts the cyan, and then it says, well, if I have subtracted the cyan, the color is red. So reality is red, right? You can do all those kind of things. Right, number one, this was the prologue. Number one, we have the mountain of joy and the valley of despair. It's getting harder, right? IT is getting harder. Large, complex logical landscapes are increasingly hard to change. Transformations are slow, costly, and they often still fail. And why is that? Well, it is harder and harder because logic essentially is rigid and dumb and brittle. Just one bit wrong in the 112 system in the Netherlands, the emergency phone system, in 2019, and the thing went down. And it doesn't help for continuity that you have put up really 4 of these to make sure that always one is doing, because it was a logical error, which meant they fell down all 4, because it's the same thing, logically. Logic is brittle. Logic cannot handle things that are not exactly expected. So we have created in the world a landscape of loosely coupled spaghetti of massive amounts of brittle logic. That's what we have done. And as a result, all that machine logic we've put into society and into our organizations shows something that looks like mass. It has inertia. It's kind of a resistance to change. So there are a lot of people in organizations saying, that's a culture thing, and people should, you should all go on a course on becoming more, mentally agile. Well, the people also are embedded in very brittle logic that is very hard to change. So what we are looking at is not a singularity point. What we are looking at is a complexity crunch. Society is on the road to a complexity crunch. And there are indeed 2-speed ITs, bimodal 2-speed. Not like the Gartner or McKinsey said it, like, you have fast changing apps on the outside and the slow changing stuff on the inside. No. New IT, new stuff, adding something is easy-ish. Changing what's already there is hard. That's the 2-speed IT. So if people ask me, what's your definition of architecture? And there are really many definitions of architecture in organizations and landscape. I say, well, that's what is hard to change. And I was not the first one to think of that, because Grady Booch thought of that in the 80s. And Martin Fowler, when he was talking about agile, etc., he said, well, the stuff that we call architecture is the stuff that is hard to change. That is what architecture is. And by the way, you see, as this is kind of a farewell talk, right? So I'm kind of out of here. You see the links below. There are articles below that. If you have the PDF later, you can click that and you can read the stories behind it, etc. Now suppose we look at the IT revolution as kind of an S-curve. Most innovations go through an S-curve. Then at some point it starts, then you have this rapid growth phase, and then kind of you get in our case probably the complexity crunch, and it's going to slow down again. But the interesting thing is that in the middle, speed is fast. Our tech bros, and most of us, we grew up in a rapid growth phase, right? So our experience, what we have experienced, is rapid growth. But what happens if we going to enter the complexity crunch? Before you have a speed of change that exceeds expectations. So it's always faster and more than you actually expected. But on the second half, the acceleration is negative. What that means is that the expectations constantly exceed the speed of change. So now you are in a business as an architect, especially as an enterprise architect, that the people who are kind of the business, right, they want speed, and you're in a position to constantly have to tell them, no, not so fast. That's kind of the valley of despair. So it used to be fun. These days, it is painful, which means that I'm out of here. But don't take this too seriously, because it wasn't all fun in the 90s and the zeros, right? But this was one of the few posts I did, which actually went a little bit viral on Hacker News. That was this one's called "Don't Become an Enterprise Architect." Really do not do it. It's going to be very nasty business in the coming years. Of course, again, don't take it too seriously. There are always happy areas and niches where change is still new. Containers, infrastructure as code. There are always areas where you have these new developments with rapid growth, and these are really fun. So if somebody asks me, what's the IT revolution? I say, well, that's kind of gaining productivity, speed, power, volume, at the expense of agility. That's the key thing. By the way, there's a second key thing, which now kind of arrives with generative AI, that is lowering the price at the expense of quality. Right? It's very cheap to let Midjourney produce kind of shoddy output, and you don't have to pay your digital artists anymore. So that's kind of, that happened at the start of the Industrial Revolution too. The initial weaving machines, they produced shoddy results. Interesting thing is they destroyed the market for the good stuff because it was cheap. So there's what the word cheap means. Cheap doesn't not only mean, in our language, doesn't only mean cheap to buy, but it's a cheap product. It's not very good. So what's the challenge? Well, fighting the crunch is a challenge. And actually challenges can still be a lot of fun, right? Getting that last hundredths of a second from a record can be an extreme challenge and can be an extreme motivating thing. And there are two ways this can be a fun. One is realism. If you really know what you're doing, etc. The other is ignorance. Ignorance is bliss. There are lots of architects who think generative AI is going to solve everything. They tell their management that you can kind of throw away all your coders because generative AI is going to do it for you. These people are very happy. It's very happy people. In a sense, if you look at if your goal is getting a human on the moon, then the realist kind challenge, let's try to do it. And the other one is the ignorant, Gen AI is going to do it for us. Only one of those is going to put a human on the moon. So how have we been reacting to that crunch? Because it's not new. It's been with us for as long as we have an IT revolution. Well, we have a simple pattern. We standardize or encapsulate. With that, our agility goes up. Then we grow, more productivity. And because we have all this extra stuff, agility goes down again. And then we return to step one. And there is, of course, an XKCD comic for this, right? The guy is brilliant. So encapsulation doesn't remove anything. It just reorganizes it into manageable chunks, and it hides it. Encapsulation assumes independence. And I say assumes because it's not always true. For instance, I have had a period where we all went into service orientation. And everybody was decoupling because that was the thing to get everything agile again. Right, but if I decouple something technically in the sense that I have an accounting system and a sales system, and if the accounting system isn't available, the sales system crashes. Then I go do a technical decoupling so that if the sales system, the accounting system is there, the sales system doesn't crash. Nice. However, it still doesn't work because logically you can't decouple. You can decouple technically, but the whole landscape is still a logical dependency. All these things, if they are not there, make sure that your landscape does work. Put all your systems in different SaaS solutions, thinking that you have created a more secure way to prevent, say, the whole landscape being ransomware. Sure. But if one of those falls down, your whole setup doesn't work anymore. And now the next question is, how many different attack vectors are there now that you have put it in at 10 different providers? No free lunch. And of course there is the risk of that hidden stuff rearing its ugly head. Log4j, anyone? Suddenly it was everywhere. Suddenly we found that vulnerability. So what have we been doing? Well, functions was the first one. Object orientation, 70s, 90s. Service orientation, system landscape, 1990s. Here's another one. Agile development. Agile development is also a form of encapsulation. It's become so complicated and complex that we say, well, let's organize ourselves in kind of encapsulated teams with that product in the middle, with a product team and a product owner, etc. We don't have project managers anymore, we have product owners. That's encapsulation. Again, technology moves on, containers. Then we have DevOps and SecDevOps and BizDevOps and BizSec DevOps. It's the same kind of thing. We're going to encapsulate. We're going to fragment the organization. And talking of that, I don't know if you ever heard of Conway's Law. Of course, okay, I'm going to tell it anyway. But Melvin Conway was an engineer in the 60s, and he came, he visited companies and he said, well, that's really weird. If they have a separate sales and marketing departments, then I find a sales application and a marketing application. Whereas if I come in a company and they have a combined sales and marketing department, I find a combined sales and marketing application. And Frederick Brooks, the famous Frederick Brooks from No Silver Bullets, he coined that Conway's Law. He said, the IT of the organization follows the structure of the organization. And this was true for a while. But if you look these days, it's kind of inverse. So what happens is that more and more, we flexible humans are organizing ourselves around inflexible IT, hard to change, difficult, etc. IT. So, which means that now, instead of the organization running making the structure of IT, the structure of IT is actually creating the structure of the organization. And of course, so what has happened is that in a classical company, you have your purpose, your why, and your goals, etc. That leads to some sort of human organization, and then you have the IT to support it, right? And then you want business IT alignment. That was the big thing in the 90s. These days, we have a purpose, a why, etc. that translates for a lot of companies into a lot of IT. And then we as humans organize ourselves around that IT. Of course, the other thing also still exists. We still have purely human processes and etc. So did I mention it was becoming more complicated? Yes, I did. So there is a next level coming up. That is the encapsulation of business units. So you have these large firms and they have separate business units, and the business units are going to say, why do we have one IT department for our infrastructure? Can't we do that ourselves? We can go into the cloud and have our own IT, right? So again, this same pressure of being able to manage all that complexity is kind of now pulling at companies. And of course, that may be in conflict with the necessary coherence of a company. So some companies will not be able to do that because they are so interdependent that they can't. Some companies which actually are not more than, say, a collection of separate concerns, they might fall apart. And the question I ask people, how important is it that they are all in the same identity and access management solution? Because if that's the case, because they have to work together on documents all the time, etc., then you have a lot of coherence in your organization, and you're going to run into this part of the complexity crunch because you want to fragment further, but you can't. And if you try, by the way, it's a recipe for trouble. Now, architects love abstraction. And one of the things really enterprise architects like to do is go at the business strategy level, right? Work with capability maps and business functions and etc., etc. From my personal experience, that is very important, but it's only 5% of what is needed. It's only 5% of the effort. Because most of the effort needs to be spent on things that actually have an effect on the shop floor, the actual real design decisions are being taken. There are lots of enterprise architecture initiatives who produce beautiful capability maps and principles and all that, and after a couple of years you still have the same problem on the shop floor.
Because those people don't read what was produced there, or don't care.
Or they don't care, right. Well, personally, I'm talking about my personal experience, strategy or enterprise architecture through planning and principles is often a very seductive illusion. And let's take the example of the architecture principles, really a popular tool in the architect's toolbox, right? What makes a design choice you make, not kind of a soft guideline, but what makes it a principle? The principle comes from comply or explain. Comply or explain is a contradiction because you are saying two things at the same time. One, if you follow the principle, it's always good. By the way, if it's not good, you can't say it's always good, and in the same sentence say when it's not good. What happens here is that the really good architects, they don't need these principles. They are experienced designers, they have them in their head. You shouldn't put the architect in the principles, you should have the principles in the architect. So they don't need to be told of the positive side. But the poor architects, they will actually apply the rule when it's a really bad idea, because they don't recognize the negative side. And I can tell you, I have seen projects, the GPS project of the Dutch Ministry of Justice, between 1998 and finally in 2013, they admitted it had totally failed, nothing to show for it, and it had cost 150 million euros. If you look back, what went wrong, it was an architecture principle. The architecture principle led them to a setup that could never work, but they didn't recognize it.
Now you make me curious what the principle is.
Later.
Okay.
So there's another thing. If you have an organization with a heavy use of principles, it's kind of a sign of a weak design culture. Often the IT department was weak, the business was creating a chaos, and the IT department went kind of, please, top of the company, put this in law so that we can actually get them in control. But it's a sign of a weak design culture. So, if you ask me, architecture principles are toxic. Handle with care, preferably stay away.
Or just ignore them.
Which is what happens, right? Okay. So the real IT decisions are those that have an effect on the shop floor. All the other ones are meaningless. And this is an interesting thing I've seen. I've got a network of people I know. And generally what happens is this. There's a new enterprise architecture initiative. Everybody starts and they produce these nice simple pictures so that the business says, oh, that's one. I want that one. Not the mess I have now, I want that one, it's clean. And then after a year, everyone says, what's happening? There's nothing. And after 2 years, they say, well, you're really dissatisfied. Everything is still the same. And after 3 years, this is kind of the enterprise architecture board game, we're going to reorganize. The average lifespan of an enterprise architecture initiative between reorganizations is, in my observation, between 2 and 3 years. Except when it's really done well. Of course, there are exceptions, but generally this happens a lot. There's a second thing which is very important. Enterprise architecture that cannot be shown to effectively influence decisions that support a future strategic change is damaging. And what do I mean with that? Well, your current business strategy is not a good basis for architecture. The average lifespan of a business strategy is about 4 years. The average lifespan of key elements in your landscape is maybe 15 to 20. Put TIPCO in, try to get it out. Which means that if you have an idea that enterprise architecture is like executing a strategy, that's wrong. Because if you do that, you kind of super glue, nail, and screw you to your current strategy. It's very important, and it is a challenge for everybody here because of the IT revolution, that businesses now not only have to think about, I am executing my strategy, but after me a next CEO comes. And he wants to change the strategy, by definition. So is he going to be able to?
Are you now saying that the business strategy is not, it is, in my opinion, at least an input? It's not the core foundation.
Certainly, but the framework say,
base it on.
You start, Togaf says, start with principles, then you have your business strategy, and then your IT strategy, etc. That's all that's the business IT alignment from simpler times. These days, your landscape is so hard to change that, in my opinion, maybe 50% of your effort should be directed at keeping agile, because that's the fight. We're not in a fight to get the functionality running, we're in a fight of our life to actually be able to keep moving, to keep changing. So, when will we be successful? When legacy has become a positive term. That 3 years from now people say, man, I'm glad we chose that one 3 years ago. Because that's the legacy. Or 5 years from now.
At least that works.
Eh?
At least that part works.
That too. Right. For me, definition of abstraction is consciously leaving out relevant details. So a lot of people who abstract, they do not consciously leave out details, they ignore details. There are a lot of people who can do very simple, high over things, ignoring all the details, but people stumble over molehills, not over mountains. Right. A second thing which may surprise you, there is no such thing as a non-functional. Why do I say that? Well, do you know where the word comes from? In the 60s, it were the mathematicians who started to do the programming, Edsger Dijkstra and people like that. And they were thinking in functions as mathematicians do. So I have something with input, ax plus b, x is the input, y is the output. Inputs and outputs. That was a function. So if they created a function and somebody said it's too slow, then they said, listen, mathematically my function is perfect. So buy faster hardware. And that's actually what happened. It has taken us about 40 years to actually pay a lot of attention to algorithms, which is a very extremely new form of mathematics in terms of what the mathematicians are working on. But they say it's the function, y is ax per b, how fast it goes, I don't care, as a mathematician, I'm not interested. That's where the word non-functional comes from. It comes from math. Now suppose you have a function, right? This is your function. So is that enough? Well, no. Because we have all kinds of things around it which we have to pay attention to, like disaster recovery. We have to change the function. We have security. We have log and monitoring. And let's talk about performance for a while. Suppose I do something called cash management. Cash management for an asset manager means at the start of the day I have an amount of free cash and I do intraday lending. So I lend it at the start of the day, I get it back at the end of the day. People can complete transactions with them, they pay me back at the end of the day, and I make money of this. When I thought of this example for the first time, I think then still ABP was still making 25 million a year just from using the free cash to do intraday lending. So that's kind of worthwhile, right? That market opens at 9. US market closes at 10. You have to do all these administrative things, backups, etc. You have to do your calculations, value at risk, external parties, all those things. What happens if your cash management calculation finishes at noon? There is no market anymore because the market is in 9 in the morning, between 9 and 10. At noon, it's gone. So, do you still have that function? The mathematician says, yes, I have the function, cash management. But on the enterprise level, you say, no, I don't have cash management. So, every non-functional is a functional at the enterprise level. You have to look up beyond the level of the mathematician, beyond the level of the programmer. And by the way, that's not all, because we have these, and we have these, and we have much, much more that plays a role here. So why are we always talking about that one? Why is the business only talking about, I have cash management, and I pay pensions, I sell books, those kind of things? That's kind of very myopic. But it still exists, it's still a problem. So, for me, architecture, it must be holistic. Risk and control, part of architecture. Security, part of architecture. Performance, part of architecture. Systems and resource management is part of architecture. Future change is part of architecture, etc. As far as I'm concerned, all that attention to functional purity, I had this one guy come up and he said, we're from innovation and you're from security. I don't think so. But people really believe that they can actually be only owner of that little thing in the middle. So only in an imaginary world is something like continuity of your IT a non-functional. Non-functional continuity? That's, I'm kind of reminded with discussions between, I think it was Turing and Wittgenstein, who were discussing, is zero telephones also a telephone? This is really crazy. How can you say that continuity is non-functional? It doesn't exist. So, concept of non-functional is utter nonsense. All of them are functional at the enterprise level, and if they aren't, you shouldn't bother about it. Number 3.
It's just that we just call them that, right?
Semantics.
Yeah, what I agree with is, as an architect, you have to care about all of them.
Yes,
but
no,
naming,
not just as an architect. That's the point. As a business, you have to care about all of them. Because if the business says, that's not my concern, that's your concern, you're dead.
One of the things that was...
I guess we're the best in the room to help with that and point at it.
I'm going to get to that. So, here's number 3. If you're dead, you don't move. We all know that. Dead, don't move. If you stop moving, it's very bad for your health. If you be a couch potato and a keyboard warrior entire life, then you won't get very old. Life cycle management, removing technical debt. Wrong word, by the way. It's mostly technical risk. They may feel like not having that functional advantage, right? That's why we don't pay attention to it. So, because as a business, what does it do for my business? What better function do I get? What are my features that I get, etc. But at the enterprise level, they are essential for your health. And that's related to what architecture is. So that was number 2. I'm going to do number 3. And then probably, I don't know if you have time for a break, so we'll see. I was talking at the start about there are 2 important things. Knowing something about IT and knowing something about humans. So this part is called, you have to pay attention to human intelligence. Forget generative or whatever artificial intelligence, but you have to look at human intelligence because you're in the business to convince people. That's a human business. That's a human thing. And the higher up you go in the organization, by the way, down, same thing, but the higher up you go, there's this special problem. That is, they are so far away from the actual complexity that has a negative effect on decision making. So what you get, for instance, is the architect's catch-22. The architect's catch-22 is that say the board of directors of a company tells you, please tell it to me in a simple way. And as good architects, we can actually do that because we have the ability to understand the complexity, but we also have the ability to kind of abstract it to something other people can understand. We are all kind of good storytellers. But what happens if you tell a very good, simple story? They start to believe it is simple. And that's the catch-22, because as soon as they think it's simple, they're not willing to invest in the effort anymore. And if things don't go really well immediately, they are going to ask who's to blame. So there is a catch-22. You want to make it simple, but if you make it so simple that they start to believe it is simple, you've done something wrong. And again, we have the molehills versus mountains. Now, how humans decide is kind of key in IT strategy and enterprise architecture. Now, if you look at human intelligence, it has evolved as a variable mix of two optimizations. One is an optimal fit for individual success. So I walk high grass, and I have to know immediately, is there a tiger there? It's not at that point that I'm going to think, wait, that is orange, is that orange? Yeah, that's also black. That could maybe, no, tigers are orange or black, could it be, I'm done, right? I'm gone, I'm dead. The other one is we're optimized for tribe success. That's called Dunbar's number. It's actually corroborated that if you go to say in the jungle in the Amazon, they are roughly 150, 200 people large. If they grow larger, they split. The reason for that is we are able to actually maintain trust relations and know-how about everybody, etc. And so we can collaborate very well. It's very simple. You know, if I go hunting and every day my neighbor is doing something different, that is kind of, you know, I will never catch anything. So you have to trust each other. You know what the other is doing. You know who's trustworthy. You know who's fast. That is where we optimized for. We are optimized for these two, individual success and tribe success. And, more importantly, we are optimized for speed and efficiency and not for thoroughness. So, the key element that enables us to act quickly and efficiently is the conviction, right? Assumption, belief, standard reaction. We have convictions. And what we actually most of the time are doing is mental automation. So we are lightning quick in all kinds of things that we kind of find. So what happens then is exactly the same as in the IT that we know, because we have increased productivity, and it's, by the way, also efficiency, 20 watts, very fast, but it's paid for with a decreased agility. Because this is kind of malleable instinct realized by malleable hardware. If I want to change my convictions, I have to change my neurons. That's a physical process. We are hardware optimized to the hilt. We don't have hardware and software, we're kind of malleable hardware. And that has also results in terms of how fast we can change our convictions. So we have, of course, built much larger structures than tribes, right? We have built organizations of thousands, tens of thousands, hundreds of thousands of people. Countries function with billions of people. If you look at why they function because they have shared convictions. That's the reason why, for instance, information warfare is so much directed at breaking our shared convictions. Because you can actually really damage a society by that. And it's brittle. So, summary, how humans make design decisions is key for organizations if you're an enterprise architect or IT strategist or whatever. But humans aren't very thoughtful. By nature, we mostly have automated, quick and dirty assessments. And let me stress that. Most of what we do when we are thinking, doing, talking, acting, discussing, etc., is automated, quick and dirty assessment. Like now. And I'd like you to take a step back, because I've done all these very harsh statements. Principles are toxic, there are no non-functionals, all these things. How long did it take you to actually have an opinion on that? Instantly. That's your mental automation at work. That's your convictions. And we all have them. Because that's how our brain works. So we have to understand how IT works, but we also have to understand how our brains work, because if I'm talking to other people, they have convictions. And the interesting thing is that we tend to believe that our convictions come from our observations and reasoning. That's what we believe. Actually, it's slightly. Our convictions are influenced slightly by our observations and our reasoning. But the other way around is much more true. Our observations and reasoning are really strongly influenced by our convictions. In the most extreme cases, say a hypnotist convinces you of something. For instance, he convinces your brain that you don't know what the capital of the Netherlands is, and you're kind of like, I don't know.
This
right?
is what changes so hard. right?
Huh?
This is what changes so hard.
Yeah, this is kind of what the hypnotist does, is hacking into your
Yeah.
brain. But there are
Normally.
but what happens is that if I see an article and they go to tell me the new LLM configuration from OpenAI O1 is going to really be a massive change, I have a conviction already that it's not possible for the technology they're using. So if I read that article, I'm going to look for the things, that's a quick step you can't make. So my conviction steers what I see. And there are many ways in which that happens. So that's why it's not only true for, say, conspiracy theories. It's kind of, it's true for all of us. We see what we expect to see, and that's kind of also the efficiency, because our brain says, listen, all the things that aren't relevant, I don't want to spend energy on this. Only 20 watts, right? And so you don't want to spend energy on all those things. So what happens is your automation kicks in and says, irrelevant, 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 irrelevant. I can share one thing. Personally, when I watch TV in a football match, I start to shout before I am aware that the goal goes in. Shortly before. That's my subconscious, which has already detected it's going in. I kind of experience that. So you can experience the lag between what your unconscious is doing, and what happens often is that all the things that actually you might observe don't reach your consciousness, because the consciousness says, no, it's not relevant.
Thinking fast and slow, right?
This is partly also thinking fast and slow. Yes, yes. I think it's not so much fast and slow. It's kind of automated, non-automated, right?
Yeah.
That's why it's a good noise.
Okay. So our convictions are created from learning, personal experience, yes, but a lot is done from copying. We are copying machines. We think we're smart, and we tend to believe we're smart because that's good for ourselves, but we're copying machines. Look at influencers. Why do we have these massive influences these days? Well, look at that screen. Person you're looking at, they are in your face. They are a close relation. And they talk to you as if you're a friend. And the social media is making sure you're getting the same all the time. Those are the two things, how we come to convictions. From things that come from close, or things that we see or hear often. That's how we get our convictions. So, social media and influencers, they actually hack directly into basic working of our brain. So, there are researchers who say, and there's been kind of an idea that the human intelligence is that kind of, you have the senses, and in consensus out goes actions, right? And driving a car, etc., etc. But frankly, everything with sense organs does that. Even plants close their flowers when the light goes away, or move, or whatever, etc. The thing nobody ever really talks a lot about is that we have imagination. Imagination means that we can think of things that aren't there, or aren't there yet. It leads also to kind of modes of thought. So we can think about possibilities, about opportunities and risk. So related to the term abduction. Abduction means, deduction means if it's rain, it gets wet, right? Induction means all the times I see wet, it also had rain, so I have made the induction, rain makes stuff wet. But the other way is, I see the street and it's wet. What has happened? Well, maybe it has rained, maybe a truck came past with cleaning the street. What has happened? That kind of a reverse induction is something which computers are really, really bad at, because they don't have the imagination to have all these kind of possibilities. All right, we go back to humans. It can happen that strong convictions are mostly based on those imaginations. For instance, all these silver bullets that have come by during the decades past, right? Code generation in I think in the 80s, 90s already. Various cycles of hype on AI. When Watson won Jeopardy, that we all were that everybody was saying, general intelligence, artificial is around the corner and they're going to solve all our problems. Object-oriented program, blockchain, a nice one. 5 years ago, blockchain is going to change everything. So, we humans accept what we experience as reality largely on autopilot. So we are vulnerable. And we do not actually experience reality, but we have an interpretation of what is reality with that chessboard, right? So, and that is mostly based on what we are already convinced of, because that's our automation talking. Which means that we are also rather inflexible as humans. Now, we can create collaborations, and we can do those in two ways. One, we can make collaborations more intelligent, a tribe, a team, science, value-based societies, or less intelligent, a mob, a dictatorship, too much bureaucracy. So go beyond the tribe size, and you get these challenges. In my personal experience, and thus conviction, success comes from quality collaboration. Nobody can know everything about everything, etc. It doesn't come from parallel instinct. Giving everybody the same North Star and then say, if we all go in the same direction, everything is going to work out fine. It doesn't really work. It's a very dumb way to do it. Top-down enforcement is very risky. And least of all, it doesn't come from conflict. It's very counterproductive. You're all the time, you have to collaborate. The only way in this complex world that we get the best design decisions that we need, that is through forms of collaboration. So, summary, the key aspect for effective architecture, from my view, is understand the complexity crunch, because otherwise you're always only thinking about those functions and not all the things you have to do to actually keep moving 5 years from now. And understanding human intelligence, because how do you get actually the right decisions taken in the organization? And I'm going on. I'm doing the last piece in one go. It's okay with you? Yes?
Absolutely.
All right. So I have some practical tips. Still work.